Hi, my name is Mason Fike, and I'm going to be presenting on Figure 3 from factors affecting date of implantation, parturition, and date entry estimated from activity and body temperature in free-ranging brown bears. The study and all the data was collected by Freed et al. So first we're going to get into some background information, brown bear reproduction and hibernation. So brown bears are unique because they give birth during hibernation, and during their gestation period, their body temperature rises and then stabilizes to support the growth of the fetus. And after parturition, which is the birth of the cubs, it goes back down to baseline and it fluctuates again a little bit. So the study compares pregnant versus non-pregnant bears and the temperature variations that are shown by those bears. So the figure uses a box plot, which is useful because you can see the outliers and the main middle point of the data, the middle line being the median. The box plot is very useful because it helps to reveal the patterns related to the pregnancy status of the bears, and in the figure they group pregnant and non-pregnant bears, and they also group them by stages: pre-implantation, gestation, and lactation. So you can compare on the box plot, which here it is, figure 3. You can see these are the pregnant bears with the pattern. The white here is the non-pregnant bears, and then they've grouped each of these into the 3 stages of pregnancy: pre-implantation, gestation, lactation, and the same for the pregnant bears. So the y-axis is going to show you the daily temperature variation in their bodies. So right off the bat, the first thing you can see is just how little the temperature varies during gestation, which again, that's going to be the period of time that the fetus is growing inside the mother. And then the other thing that you can see immediately is how much less the body temperature varies in pregnant brown bears overall as compared to non-pregnant brown bears. So they use temperature variation is super important for them because it's a way to tell the status and the pregnancy status of brown bears non-invasively without actually going and testing them. You can just track their body temperature, and once you see that it's just fluctuating very, very little, then you kind of can tell that bear is pregnant. And also, the statistical tests show significance with a p-value less than 0.002. So conclusion, why does it matter? What does figure 3 actually tell us? So the big takeaway is that pregnant bears stabilize their body temperature during gestation to support the fetus development. The stability distinguishes pregnant from non-pregnant bears and highlights how body temperature can be used to non-invasively track reproductive status. This information is really important for conservation and to help scientists monitor wild bear populations without disturbing them.